All right, so this is the 12C handout. So 3D shapes, basically, and or 3D solids. And so number one is asking about the surface area, which is the same thing as total area, of a cube that has sides of length 2 centimeters each. So 2 centimeters here, 2 centimeters for the height, 2 centimeters right there too. 2 centimeters. Yeah. Oop. Make that a little bit neater. Okay, so if you think about it, it's 6 squares, all 2 by 2. So if I did the area of one face of one side of the square of the cube, it's going to be 2 times 2, so 4. And then a cube has 6 faces, so total area, or if you prefer SA for surface area, is going to be 6 faces times 4 4 per face, so we get 24. Okay, and 24 is the total area. Since the lengths are centimeters, this is going to be centimeters squared for an area. So it's 24 centimeters squared. Okay, so let's take a look at number 2. So number 2, this shape here, it's supposed to be an ice cube, except that there's a hole missing. There's like this cylindrical hole right in the center of it. So the ice cube is all of the stuff around the cylinder, right? It's the inside the cube, outside the cylinder. So that this thing right here is hollow. That in this inside. So and I don't know if you've seen these types of ice cubes, but you see them like at movie theaters or at hotels a lot of times. That they have the ice that has the holes in them. So in this, it's really the same cube that we had in number 1, except now that I've drilled that cylindrical hole out of the middle of it. So the first question is, what's the volume of the ice? And if you look down here, I also drew kind of like an overhead view of the base, right? So it's that square with the circle cut out of it. So volume, now this thing works just like a prism because the bottom and the top are identical, and it goes straight up and down here. So the volume is going to be the area of the base times the height of the prism, or in this case, whatever that shape is, times height of, I'll just say, of the ice. Okay, so the area of the base, well, here's the base down here. The area of the base is the blue part. So it's the square, this whole square, minus the circle. All right, so area of the base, area of base is going to be area of the square minus area of the circle, which is going to be, let's see, the square is 2 times 2. And then we're going to subtract pi r squared, pi 0.5 squared, times 0.5 squared. And so then, let's see, if you work that out on a calculator, you get 3.2146. Okay, so that means that the volume, if we come back up to here, the volume is going to be the area of that base. So that's going to be 3, oh, the marker's not working well here, 3.2146 times the height of the prism, that's a dot there, times the height of the prism, or the ice, which is 2, right? So times 2. And that comes out to be 6.430 if you round to 3 decimal places. And so that's going to be, since it's volume and we're working in centimeters, this is going to be centimeters cubed. So I think there's a spot down here for volume. Yeah. 6.430 cubic centimeters. Okay, so that's the volume. Let's take a look at total area, or surface area, right? So surface area, or total area, well, we've got several things to add up to figure that out. So we've got the area, so that's surface, it's everything you can touch, basically. The top, the bottom, the outer walls, and then actually there's the inner walls, right? Because you can touch the inside of that cylinder there. So let's kind of write out what we need to do. We need the area of the 4 outer walls. And then we're going to add in the area of the top. We need the area of the bottom. And then the part that I think people forget is the area of this cylinder here, right? We can actually touch that because there's a hole there. You could just kind of reach in and touch the inside of that thing. So that's part of the walls too. So area of, I don't know, let's say the cylinder wall. Right. So let's figure out what these areas are. So the outer 4 walls, so let's do this. Area of 1 outer wall. And the outer walls, I mean these things right here, those guys. Right, so that's one of them, and then here's another one here. And then there's one in the just around the corner right there. And then there's another one back here, right? So, and they're all identical. They're all 2 by 2. So each outer wall is 2 times 2, which is 4. And so the area of the 4 outer walls will be 4 times 4, but we'll get back to that. Okay, so then the area of the top, that's the same as the area of the bottom. And we figured that out already. That's the base. That's the 3.2146. What else? Oh, and then we need the cylinder wall. Okay, so the cylinder looks like this. And there's no top or bottom to it. It's hollow. So what I want you to picture is it's like pretend that there's a label on this cylinder, and I've cut the label right there, and then I start to unfold it, right? So if I start to unfold it, then I get something that looks like this. Oops. Oh, that's right, yeah. Right, so you can kind of tell here's the label starting to unfold, and then if I unfold it all the way, oh, and by the way, the blue line is the cut. So this is where the blue is now. And then when I unfold it all the way, I get a rectangle right there. And here are the blue parts right there. Right? Now I know that the cylinder, this height of the cylinder right here in the original diagram, that's 2 also. So this is 2. 2. 2. And this part right there, oh shoot, hold on. This part right here is the same thing as this part right here, which is the same thing as the entire circle up on top. So if I wanted the area of that cylindrical wall, I just need the area of this, of the rectangle, and the green parts are all the same. So I'm going to call that L for length, L. So then notice L is the same thing as the circumference, right? So this is actually 2 pi r. So let's see, the radius is 0.5, so L is going to be 2 pi times 0.5, which is actually pi. So then the area of this thing is going to be 2 times pi. So let me write that out. So the area of the cylinder wall is going to be the length times 2, which is pi times 2. So I'll just write it as 2 pi. Okay, so I've got the outer walls are each 4, the top is 3.2146, and the bottom's 3.2146, and then the inner curved wall is 2 pi. So let's add them all together and figure out what we get. So total area, or surface area, is going to be the 4 outer walls. Well, each wall is 4, so I need 4 times 4. And then the top and the bottom are each 3.2146, so I need 2 3.2146s. And then, so let's see, what have I got? I got the 4 walls on the edges, I've got the top and bottom, I need the cylinder part, so that's 2 pi. And then if we plug all that into a calculator, you end up with 28.712. So 28.712. And since we were working in centimeters, area is going to be centimeters squared. Okay. Now the question at the end here, why do you think ice cubes with holes in them like this even exist? Right? So it turns out if we compare the surface area, so notice this one up here, this one's solid, right? And its surface area was 24. And it turns out if you actually drill the hole in it like this particular hole, you've actually increased how much surface it has. You've decreased its volume, for sure. If you remove space from the inside, it doesn't have the same volume. But if you cut certain types of holes in it, you can actually increase how much space there is to touch on it. So, the cube, or I'll put cube like this because it's not a solid cube. The cube in number 2, so with the hole in it, has more surface area. Oh my gosh, this thing is terrible at writing right now. Has more surface area than if it were solid, than if it didn't have the hole. Oh, God, have the hole, like in number 1. Well, if it has more surface area and you throw that ice cube into a drink, more of the liquid is touching the ice that has the hole in it. So that means more liquid is touching the ice's surface, let's say. So if you think about it, if there's more liquid touching the ice, then it cools faster. So it'll cool the drink faster. So not only does it cool the drink faster, but it uses less water. So you actually would be saving money, depending on how much water costs. But that is a save. If you save in volume, you save in money. So, okay, I hope that helps a little bit, and I'll see you guys soon.